So we're going to talk about the pieces that you need for the math of machine learning. We're going to look at vectors, we're going to look at functions, we'll look at optimization. And these are the three fundamental pieces that you really need to understand how a machine learning algorithm creates a function. So let's start with vectors. We're going to look at the space Rn. This is the real numbers n times. And this is the space of tuples. So when I do tuples, I put on, let's do k instead of I. That will go from k equals 1 to n. And each x sub k is an element of the real numbers. So for something concrete, for instance, we could look at r cubed, which would be the set of things that were tuples of the form x1, x2, x3, such that each of these is a real number. So for instance, you could look at the element 2 for pi, this triple of real numbers, which will be an element of r to the third. Distinct, you could have 1, 1, 1 in r to the third, and order does matter. So if you had 4 pi 2 in r to the third, these would be distinct vectors in r cubed. Do we care about this? How does that apply to our situation in the looking at machine learning problems? Well, if we think about a data frame like we've been looking at, we typically have features, which are the columns that we'll use to predict. And then we have the target, which is the single column whose outcome we're trying to predict. And if there are n features, then we could view this collection of numbers as a vector x1, x2, up to xn. In other words, each row of the features of a row like this would be something that lives in r to the n. This would be a vector. And then we have our target, which is just a single real number, y, and that would just be a real number. I'm assuming here that I'm doing regression. My data set takes n-dimensional vectors on the one hand and associates them to real numbers. So I have input, output, just like a method. It's a function, right? And my goal is to take this relationship, and I want to build a function that will take a vector, an n-dimensional vector, and predict the output based on the observations that I've seen. I want to build a function that can predict it for any n-dimensional input vector. For instance, if we looked at r to the fourth, there's actually two different ways we could look at representing that. There's the row vectors. For instance, we could have 1, 2, 3 pi, and it would be on its side like this. Or we could look at the column vectors, which would be 1, 2, 3 pi. And they're the same numbers, but they're represented differently. That's going to become important later because we'll be looking at something where the row vectors represent one thing and the column vectors represent another. It's not super important right now, but let's just be aware that when we get to that point, it will be the case that these are distinct things, even though they represent theoretically the same. So now, since we have r to the n, since we have this vector space, we can define functions that take vectors as input and spit out real numbers. So to define a function, we need the domain, which is the set of possible inputs. We need the codomain, which is the set of possible outputs. And we need a rule that associates each element of the domain to an element of the codomain. So we're going to be looking our functions that we want for machine learning. We'll go from Rn, where n is the number of features,